Hi everyone, and today I'm pleased to go through with you TaskGen tutorials. So without further ado, today we'll be covering tutorial 0, which is how to use StrictJSON. So going to the Jupyter Notebook, StrictJSON is actually a wrapper I created about 2 years ago that helps to output large language models output in a JSON format, and it has type checking, and it also does iterative correction of the JSON if the initial JSON is generated wrongly. So StrictJSON is already inside the TaskGen itself. So what you need to do is firstly just follow the steps. Install TaskGen AI, import the modules from TaskGen. Okay, and then if you are using OpenAI, you import your OpenAI key here. If not, you just import whatever API key you need for your large language model, or if it's a local model, then you can just run it directly. So next, you need to define your large language model, and this large language model takes in a system prompt, and it takes in a user prompt. So typically, the system prompt is like something that describes what the large language model would do. All right, and the user prompt would be like the thing that is acting on. Like, for example, your system prompt can be analyze the sentiment of the sentence, and the user prompt can be the sentence itself. And then your output would be based on what the LM gives you. All right, so the output for this LM function must be a string. Okay, just take note, this is very important. So it takes in two strings, the system prompt and the user prompt, and it outputs a string. So we can verify that it's working by just running like, hey, system prompt is you are classifier to classify the sentiment of a sentence. And the user prompt is it is a hot and sunny day. So the answer should be like neutral because like this is hot and sunny day. It's not very like angry or what. Maybe change it to it is a bad day. Then you can see that the sentiment will be negative. All right. So things like this, just to make sure the LM is working. So this is not StrictJSON itself. This is just the large language model function that takes in the system prompt, user prompt, and outputs a string. So what we need to do now is we need to use the StrictJSON format, okay, in order to force the output to be a JSON. And how StrictJSON works, let me just show you how this works. So again, you have a system prompt like you are a classifier. The user prompt would be like something that your system prompt is working on, like for example, the sentence you want to classify. In this case, it is a beautiful and sunny day. And the output format, you just need to specify in a dictionary or in a JSON format. Okay, what you need to specify are the keys and the values. The keys are mainly like the category of what you want. So if you want to get the sentiment, your key will be a sentiment. You want to get like adjectives, you can put the key as adjectives and so on. You can put like type of sentiment as your description here. Basically, you describe what you want to get from this field. Array of adjectives, that's for the adjectives field, and like number of words, that's for the words field. So then after that, you assign your large language model here and you print. Okay, you can also skip the large language model part. If you don't define this part here, we will just use GPT 4.0 mini by default. So you can see this is the output, sentiment positive, adjectives are beautiful, sunny, that's great. Word 6, okay, sometimes it's 6, sometimes 7, it's supposed to be 7 actually. This depends on the large language model already, all right? So you can also change like what you want over here accordingly. So let's say if I want to, add in something else like, the possible location or like possible temperature. You can put in like temperature in Celsius, right? And we can see that the output here, we have a temperature here, 25 degrees and so on. Yeah. So we can then do stuff like, hey, based on what you have come up with for this results, you can easily split it up into dictionary keys like this. Then you can just reference the result like this. So you can see that I can easily split up into various parts just by referencing a dictionary key. And this is very useful because, a lot of times when you want the large language model output, you want to parse various parts separately. And StrictJSON allows you to do that because the output is already in a dictionary for you to just extract out whatever you want based on the keys. Right, so, sometimes you want to do stuff like code. And code typically will break JSON.load_as because like sometimes you have an extra bracket, sometimes you have an extra double quotation mark or single quotation mark. So it is very irritating. And this is one of the main reasons why I created StrictJSON so that the code output can be done easily. So for example, in this case, like your system prompt is you are code generator, generating code to fulfill a task. The user prompt is like given a certain array, output a function named funcsum to return its sum, right? And then I can do a chain of thought format in JSON. So this is pretty cool. Just by making the first key, like maybe like something like thoughts or elaboration, how you would do it. Whatever that is generated for the first key will be used to condition the next few keys as well. So like I can get a C code and a Python code. So let's just run it. And you can see that elaboration, I'll create a function funcsum that takes an array P as an argument and returns the sum of its elements using the built-in sum function. Okay, so that sounds good, right? So for C code, we just loop through the array and add up the sum. For Python code, you can simply use the sum function, right? So you can then run this. You can see that the different fields, elaboration, the C code and the Python code will all be split nicely, right? Then we can also even run the code itself. So you can use an exec function here. To be safe, you can run it on the local environment and so on, because code generated by a large language model can potentially be risky, right? So let's suppose that this code is safe. All right, do some checks yourself first. All right, and you can run it out, and you can see that the output is 15 for this array, 1, 2, 3, 4, 5. So that's pretty cool. This is how you use the large language model to generate code. So, StrictJSON started out without any typecasting, because I believe that the large language model can infer quite well based on like what you write here. However, for like production use cases and something that is a bit more specific, you would want to do type forcing. This is because we want to make sure that the data type of that particular field matches exactly what you intend it to be. So I've created a type for StrictJSON. You can just put type dot data type in order to force the output field to a certain data type. So we support stuff like integer, floats, string, dictionary, list, array. A list and array are the same. It's just that array is more understood by the large language model for the JSON, because JSON list is actually called an array, right? We have code as well. Code just basically removes all the Unicode values that might break the code. So there's a special data handling for code types. We have dictionary that in this bracket here, you can put in all the dictionary keys that you want the output to have. So if your output has 2 key values like adjectives and meaning, you can put adjectives meaning inside here. Later, there'll be an example. And you can also like say, I want a list of something else, like list of int, list of float, and so on. You can put in this bracket. Same thing for array. Enum, you can put in all the choices that are possible. Like if you want like enum between true and false, you can put that inside this. You can put all the choices inside this bracket. Bool will just return true or false. All right. So you can see the details are all over here. All right. I will not be covering through this. So we will go through directly to the code example itself. So in this case, we do the same thing. You are a classifier. It is a beautiful and sunny day. And in this case, we have sentiment, and you can see that instead of just letting the large language model decide what to output, we just do an enum, like positive, negative, or other. And I find that if you put other, it might be better, because sometimes it may not fit in whatever category you give it in front. And it's forced to give you a misrepresented category. So by putting an other, it's like an escape clause. So I highly recommend you to put an other category if you are using enum. Adjectives, like we have an array of adjectives, and then over here we have type list of string, because in this case we have a list of adjectives and all the adjectives are strings. Number of words, and this is an integer. And lastly, we can also put like whether the sentence is in English, then you can put like type bool. So if you run this code, you can see that it's positive, beautiful, sunny, word 7. Interesting, you see, like after you do typecasting, the words is correct. Okay, this is based on the large language model. Nothing to do with the typecasting actually. And next, we have is in English is true. So you can see it's much more specific if you do the typing, and it's highly encouraged that you do typing, especially for production use cases, because it's more reliable. And if the type that the large language model outputs is incorrect, StrictJSON will iteratively make sure that the type is correct. So it's very useful to put the type there as well. Next, we can do even more complicated stuff, like you're an expert at organizing birthday parties. give me some information about how to organize this. Then we can say, hey, I want a quote about age. And over here, I can say type ensure that quote includes the word age. So by putting the word ensure there, we will use the large language model that you provide to StrictJSON to check whether this answer here or this field value here contains the word age. Okay, so this is useful if you want to do LLM-based checks. And if the check fails, the LLM will give a critic, and this critic will be used to correct the JSON output. So it's a self-correcting loop, all done in StrictJSON. Then if you want like 3 numbers for lucky draw, we can say type list int. And here, if you want to describe 2 venues, you can put type list dictionary of the 2 keys, venue and description. So this is very useful because if you want to, say that, hey, I want to describe my venue with these 2 characteristics, venue and description, StrictJSON will force it to be in that format. So let's run this and see what happens. And first, we can see that the LM checks whether this quote is correct. Age is merely the number of years the world has been given you. And it checks whether this includes the word age. And yes, it does. So it passes the test. So the final output is like this. Lucky draw numbers, you have a list of integers. Sample venues, we have 2 dictionaries. One is the local park with a description as well. And one is the community center with another description. So everything is according to plan. So this is the power of typing over here. Now I move on to functions. So this functions is actually meant for you to wrap StrictJSON into a function so that you can use the large language model like a function. Like if you have a large language model to generate poem based on a word, you can simply define a function to do that. That takes in a word and outputs a poem. Or like later, if you look at TaskGen, the functions can be external Python functions that takes in an external function and wraps it such that the function itself will adhere to the StrictJSON, the JSON output. So this is very useful when we pass in this function to an agent. So this function class is the default function class for equipped functions in TaskGen. Okay, so let's see what we can do in this. So I'm going to skip all this because we will go through all this in the examples itself. So the first example is like this. For functions, what we need to do is we need to have this function description. So over here, you just type in your description of this function. Like for example, output a sentence with object and entity in the style of emotion. And here you just use the angle brackets to wrap your variables. Okay, so these 3 are your input variables in the same order as you define them: object, entity, emotion. And the output would be like based on your output format. So your output is a sentence. You can put type string here also and put your LM. So you can see like after we define this function, we just need to call the function with the 3 variables like that, and we can get the answer. So like this is one. So let's say if we want to say like frisbee with cats set, we can just call the same function with 3 of them, and you can see the output. The cat watched the frisbee fly away, is heart heavy with longing and disappointment. It's very cool because no longer do you need to even call this entire function or StrictJSON. You just need to call this function itself. Back end, everything will be passed through the LM. At the front end, it looks like it's a very good function. All right, so this is really cool. Like you can just use this. You just need to define the function one time, and back end the LM will do this function for you. That's really cool. All right, so if you want to do something even more specific, like you want to say like I don't want to give any description, I just want to use the examples to guide it. Okay, this is not recommended, by the way. 0-shot description is very important for LLMs. But let's say we just want to do it as an input-output mapper. So you have some things like 3, 2, 6, 5, 3 become 15, 7, 4 become 28. So this is like a multiplication. So let's see whether it can learn from these examples and get the answer. So we put 2 and 10, so it'll be 20. So LLMs are pretty good few-shot learners. You just give them the examples here. Back end, these examples will be converted into a string and then appended to the system prompt. So you can also do the examples inside the system prompt, which is in the functions case is the function description. All right. So next up, we can even do something like we can put both the description here, like output the sum and difference of num1 and num2, and we can put examples here as well. And you can see that over here we have 3 and 4, the sum is 7, difference is 1. So all's good. Next up, we could have, multiple outputs with the variable names. Okay, so like right now over here, we can even define, like, hey, what's my type over here? Like here's int or string. Okay, in order to make it even more specific, like so this is the input type. So like int or string means like I accept either int or string. Okay, but later if you want, TaskGen to really make your type very, very exact, you should just only use one type. And this data type must be the same type as this over here, one of these types here. Okay, then TaskGen will help you to make sure that the function is output in that particular type. So over here, like int or string, fine. We'll accept both string and int inputs. Okay, and then we generate a poem in the style of this poem style and the code in the programming language here. So you can see that the output format is the sum, the poem, and the code. All right, and the input will be num1, which is 3, num2, which is 4, poem style, which is happy, and programming language is Python. So let's run this and see what happens. So indeed, we get everything correct. Like the sum is 7, 3 plus 4. So it's really cool, right? They can handle both string and numbers, right, as the input. And the poem would be like talking about 7, right, which is correct. And the code is doing a Python code to add 2 numbers. So it knows that the first input is a string, so it wraps this as an int. So I think this is like really cool that it can do something like this. And this is really, really good to play around with. And yeah, hopefully this is useful for you. So now we go to one of the more important parts for TaskGen. So if you want to define an external function in TaskGen, you should use this method. So what you do is you define a Python function, and then preferably, you should put some typing here based on type hints. Like num1 is an integer, numList is a list of integers, and then you can put like any other args or quarks that is not required to generate by the LM. It's fine to put here. So anything that is here will be generated by the large language model for your function if you put in TaskGen. So here we have this output, which is a list of integers. So what we can do is like this. We can take in this num1, and then we take in the num list, and we append this num1 to the num list and return the num list. And this doc string up here would describe how the function does it. So here we have adds num1 to num list. So later on, you will see that once we put this in the function itself, it will just take the doc string here, and whatever you see this num1, it will smartly look at your data type here and add it here like this, num1 int to num list int. So you can see everything is done for you. You don't even need to do this yourself. All right. This is basically the in-house docstring parsing of StrictJSON, and it helps you to get this function description that will be used for TaskGen later on. All right. And the input, you can see the input is all the variables, num1 and num list, to make it easy for the LM to know what it needs to output to make this function work. And the output here will be exactly like what you want over here. So like list int, the output will be of this format. So this is something that is really cool, because what this does is that it helps you to ensure that any arbitrary function that you created can be passed nicely by the LM later. So you can see that if we use this function, like we add 3 to 245, the output will be here. And this function is basically passing an external Python function into a StrictJSON function template, which will be used by TaskGen later. So take note of this. If you want to do the legacy method, is you need to define your function directly, and then you put a function description here that, like you can put a description of X over here and so on, output X in base 10 and so on. So this is similar in formats. If you remember to the internal functions here, it's similar in format. It's just that instead of using the LM to pass the function, we use the external function. So this is the legacy template, because initially the external and internal functions are based on this template, but it's actually quite inconvenient to define this function and define this description. So I've automated this process by adding this auto docstring checks. So just use this method from now on. It's much easier to do this. All right, just need to simply define your function, define your input and output data types, do a docstring that contains all the input variables. All right, and there you go, all done. All right, if you forget to define or you define wrongly, this is what will happen. Let me just show you. If let's say I forget to define num1, input variable num1 is not in docstring, adding to docstring. So what will happen is the description will be like this. And we have an additional input here, num1. All right, so if you forget to define numList or you define it wrongly, we can see that the input here will be num1 and numList. So don't worry if you miss out the input. There's a very smart error correction here that, no matter what you miss out, the function will still work later on in TaskGen. But it is better to, make sure that it works right now already so that you get the best performance. All right, some people have asked me, like, is it possible to support nested outputs? And the answer is yes. Okay, you can do nested outputs. However, for, better robustness, it is not recommended because nested outputs have a higher chance of failing for LM to generate. So if possible, if you can do it in a flat dictionary, use a flat dictionary for your use case. But if you really need a nested output, you can see that like I can put like sentiment here and I put in a list like what's the type of sentiment, what's the strength of sentiment, and so on. You can see like here adjectives, name and description as separate keys and so on. So you can actually run this whole thing. And like even the words you can put as a dictionary, nested dictionaries. And you can see that the output here would conform to whatever you put in that format. So you can stack lists, you can stack dictionaries, and it should work most of the time. All right. So do try it out. This is not recommended though. I still prefer if you use the flat dictionary, like what you've seen earlier, because it's more reliable. So some people have also asked me like, hey, is it possible instead of returning a Python dictionary, I would like to return a JSON string instead? So no problem. I mean, we can just take this Python dictionary and just run json.puts and, this will give you a dictionary. So internally, we will do this for you. And you can see that this is a string, which of course, if you take json.loadas, you can load back into a dictionary again. All right. So this part here will work for json.loadas because it's using json.puts to, or json.dumpas, sorry, not puts, json.dumpas to get this, to get from this dictionary to this JSON string. So you can always use json.loadas and get it back again. So all you need to do is to put return as JSON to be true. Right. Again, some other people have also asked me like, hey, can you integrate with the JSON mode from OpenAI? So yes, we can do that. So the OpenAI JSON mode, basically, there's two different models. One is GPT-4 1106 preview. One is GPT 3.5 Turbo 1106. This may change in the future that we can update again. So what you need to do is to use one of these two legacy models and put OpenAI JSON mode to be true. So once we do that, you can see that this is passed using JSON mode. And my experience with using the JSON mode is that the model is not very good compared to the latest model. So my recommendation is not to use the OpenAI JSON mode, just use StrictJSON. StrictJSON helps you to get the JSON out already. Just another thing to note, this OpenAI JSON mode, we don't do type checking for you here because we will pass it through OpenAI to handle everything. So this is not recommended. So if possible, just use StrictJSON directly. Async mode. Async mode is very important for a production use case because this can help to speed up the inference process of an LLM. So I must give credit to Prince because he helped a lot with async mode. So what we need to do for async mode, let's just go to the function directly. We need to do an async definition here for the function. And the client, you should use an async version of your LLM client. And typically async processes, you need to use await. So essentially we define an async LLM here. And then we use StrictJSON async. So everything is the same as normal StrictJSON, just that we put an await over here, right? And we use the async LLM down here. So you can see the answer is similar to what we get above, right? Async function works about the same way as well. So this async function uses, this is called an internal function that uses an LLM. And you can see that this async function, okay, I did not put the LM here, so let's just put So we can see that after we run this, we can get the output as well. So this is the async function mode. All right, we go to the last section. This is on additional output field checks. So this one is basically, if you want something else to do your checks rather than, just type checking, what we can do is you can have your own custom check functions for each field. So let's go to the example here. So for example, you want to do a program that generates code to print out hello world, all right? And you want to make sure that there's hello world inside the Python code. So you can have two check functions in this custom check variable. You can have the hello world check, and you can also have the function name check. So what this hello world check does is that it makes sure that, it takes in this check data, which is given over here. Like, what's your function name that you want it to be? Here, function name is myprint. So this check data is a dictionary of whatever things that you want to provide to this check functions to do their checks. So here we have this check data. Okay, and what we do is like, you have to write this out yourself. So these are rule-based checks to see whether, if hello is in the output field or not. If it's not, then you need to put some critic here, add the lowercase hello into output field. So when you do these checks, it's best to do it modular. So it's like you check for hello, you check for world, and then just add in lowercase world in the output field. Okay, so that the LM can correct in a modular fashion as well. Right, same thing for function name check. It can take the check data, and then the thing is you can check whether or not like the function name is it in the output field. If it's not, you give some critic, like ensure that the function name with that name itself, in this case is myprint, is used. So yeah, we can run this and we can put the custom checks here, the check data here, and you can see that it runs your custom checks to see whether like hello world is present. And the answer that you return here is basically you return whether or not the requirement met is true or not. So here you will return what's your requirement. And here the requirement is like check whether hello world is present in output field. And you can return whether or not the requirement is met. Here is like true if everything is correct. Action needed is your critic. So we take in these three outputs, and this will be used to, prompt StrictJSON to generate the JSON fields in the same format as what is required by these checks. So this is very similar to LM modulo, the verifiers. You can code your own verifiers here. I gave this function here so that, you can utilize the iterative correcting part of StrictJSON to run your own checks as well. So this is your own custom checks. So far, I don't really need to do this much because the LM has generated quite good output for me. But in case you need to use this option is available for you. So you can see that these are like the output for this. The Python code is correct because like it contains hello, it contains world, and it contains myprint in the function name itself. So we can also do other things like, we have a function named var1, all right? And a Python function named var1 to print hello world. So in this case, we don't have var1 until later. So like myprint. And that's why in the check data, you can put this myprint here. So, if you have certain variables that you pass in here, you can also pass into your check data directly. And yeah, you can see that the requirement is met. So there are many ways to do this customization yourself. Just try it out. Just basically for each custom check, for each key name, you put all your list of checks here in terms of the functions that are your verifiers or critics. All right, so we go to the hardest part of today. So thanks so much for listening until here. So this part is the hardest because this describes the technical details about how StrictJSON works. So you can see that what we do for StrictJSON is that we have this delimiters, hex that are wrapped around the keys itself of the JSON. And the LLM is supposed to generate out the keys of this format. So this is actually something that allows regex later on to be done on the keys here so that we can split by these keys. And it doesn't really matter what you have in this output here, as long as it's not of the form of the key delimiter, the delimiter with the keys, then it wouldn't affect the regex. So, over here, you can see that these are invalid JSON formats. Like you have this single apostrophe inside this. You also have other invalid formats like, You have this code block that has a single quotes here and outside is a single quotes. This one doesn't have the end quotation marks. And you see, like stuff like this, all these things are, are part of this another code, but it doesn't really, like, basically there's a lot of things that are not closed properly and so on. Like this one over here is also invalid because of this thing here. So let's see what happens. We have a delimiter here. You can also put the delimiter as StrictJSON. In StrictJSON, you can change it to whatever you want. But hex hex has been working quite well, so you can just keep it as hex hex. All right, so you can see that what we do is we will split by this pattern, and then we will see whether or not, you can see this the key and this the output, key, output, and so on. So it handles a lot of exceptions that JSON.load_as will fail. Okay, it will fail terribly for all this. Right? So then we will just make sure that, we remove the extra quotation marks. And then after that, we will just put them in the dictionary again. Like we'll put this key, match this key to the value and so on. And you can just print out all the key and value. And this is exactly what this output is supposed to be, right? So if there's nested variables and so on, we will do, instead of like just hex hex hex, we will do hex 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 hex. So it's like double delimiters. If you're interested, you can see the StrictJSON code for the nested part. So yep, that's all I have to say for today. If anything you want to remember for today, just remember this. Okay, first, in order to use StrictJSON, we need to firstly install TaskGen AI, then import the modules from TaskGen, set up your LLM function that takes in a system prompt and a user prompt as a string and outputs a string, which is the LLM response. Thereafter, we will do our generation by using the system prompt, the user prompt, and the output format. And the output format should contain a dictionary of keys and values. And the values can also contain type checks like this. So with that in mind, we have come to the end of this tutorial 0, and I hope you enjoy using StrictJSON. It's been used a lot in other companies as well. And like this has been quite robust and has proven to be quite reliable, even for production. So I do hope that you try it out. You can even use your own LMs you want. Try out, it works based on the last time I tried. It works for Gemini, it works for Llama, it works for Claude, it works for OpenAI. Yeah, so this is actually quite robust and I hope you enjoy using it. And with that, signing out.